Second last video. This is still the inquiry section of the energy test. A microwave is used to heat 10 grams of ice, starting with a temperature of -10. So we got to go -10 to 0. And then to a final temperature of 50. We have to do them individually. Some of you are thinking we can do it -10 to +50. No way, Jose. Wait, Jose's here? I want to say hi. Okay, 10 times 2.1. Don't change it if the units are all good. It says joules per gram degrees Celsius. I made it easy for you. Gram cancel with gram. Then I go, gram? I haven't seen gram in forever. Anyway, 0 minus the initial temperature, which is -10. So 0 or negative minus a negative is a positive. This times this. Oh, that's easy. 210. Wow, I gave 1 mark for that. Yep. And energy 2, which is the state change. This is MLF, latent heat of fusion. So we simply go 10 grams again times the latent heat of fusion, which is, in this case, because I gave it to you in joules per gram, it seems smaller than normal. So this one is 3,300 joules. And finally, Q3 goes from 0 to 50, so we're doing the 10 grams of the ice multiplied by 4.2. Yeah, I know I rounded because they're normally 4.18, but 4.2 in this one just to get it done faster, make the math easier for your brains, times 50. The one on the exam will give you the numbers as well. Remember, for the exam, you can have a study sheet. Not a study sheet, a formula sheet, but you can't write words. So these are symbols, they're okay. But you cannot put latent heat of fusion. Next, this value simply comes out to 2,100. And QT, QT. Okay, ice cubes aren't QT, are they? All right, 5,610 joules in total energy to get the ice to 50 degrees from -10. And now we're going to use the percent efficiency equation. This is the energy out. This is the energy that was captured by the ice cube. So that's E out. So we're going to use this percent efficiency equation. E out was this value. Okay, multiplied by 100. And of course, we're dividing by E in, and this comes from the electricity. Electricity. That's what we need to find. So when we put the 32%, of course, 32% gets converted to a decimal. Then I have equals 5,610 joules here, and E in is down here. E in gets moved to the other side of the classroom because he makes a lot of noise on that side. And then divide that. Okay, and this comes out to 17,531.25 joules. Of course, I don't want to lose my digits. And finally, for part C, well, that's the energy that we needed. So all we have to do is use our power equation, because power, of course, is equal to V times I, but power is also equal to E divided by delta T. So if we do the V times I, which of course is, oh, I didn't even make you do V times I, because it consumes, I gave you the number, I'm so nice to you. Look at that. Okay, anyway, this number is 1,740 joules per second. Oh, you did say, and it's on video. Okay, now we put this one on this side. We have our, okay, and divide by delta T. So of course we move the delta T to this side, we move this number to this side. So delta T comes out to 10.1 seconds. And that was how challenging that question was.